You're listening to the Australian Water Association podcast series. My name is Jo Taranto, and joining me is Stephen Lam and Hilary Chiang. Stephen is the Director of New Products Initiative, and Hilary is a New Products Initiative Engineer at Gradiant, which is a water technology company. And we're discussing the application of carrier gas extraction in textiles. Now, you're both joining me from Singapore today. Welcome, guys.
Hi, Jo.
Thank you for having us, Jo.
And Stephen, can you tell us about textile plants and why they are such an intensive industry?
So for textiles, they have very high standard for the products they put out. They have very demanding customers, such as the huge textile conglomerates like Walmart, Jockey, H&M, who have specific demands on what they want their product to look like, and they want it to be very consistent. So to have consistent products, they need the supplier or the manufacturer to create those. And to create consistent fabrics with the same color every single time, they use a lot of water and a lot of chemicals to do it. And they would like to reuse their chemicals and water, but they can't because it's already been impregnated with all these different dyes from the previous process. So it has to just be disposed of afterwards. If they have a way to kind of clean up the water, then they could reuse it. But unfortunately, they don't have that many options right now.
And so you were approached by a textile plant in India. Can you tell us a little bit about their challenges?
Yeah, so we had a customer in India, in Tirupur, who came up to us saying that they actually wanted to be more environmentally friendly, and they also want to kind of save money on their operating costs. So they had a very unique situation happening to them. In the region of Tirupur, there are lots of textile factories, and all of them send their waste to a centralized effluent treatment facility. So then the effluent treatment facility processes all the water, and then they send that for disposal into like rivers and environments. Unfortunately, a lot of the effluent treatment facilities have been failing to meet their regulatory demands, meaning they've been exceeding whatever criteria that they have to discharge into rivers, and they're being shut down. Additionally, there are only so many centralized effluent treatment facilities, so the load on them is increasing slowly and slowly, more and more, because the global demand for textile goods is increasing. So this specific customer, they had a partnership with one of the Tirupur centralized effluent treatment facilities, and they were already at 100% capacity at that plant. So they had a huge order from one of their customers to increase production. However, they couldn't do that because increasing production means increasing the amount of wastewater that you produce. So they were pretty much forced to think of something else that they could do, so they can pretty much increase their business. So what they did was talk to water treatment companies, asking them, is there a way we can solve this issue locally, so this way we can ramp up production the following year, which is very unique because when you think of wastewater disposal, you think of like economies of scale, sending it to larger effluent treatment facilities. But this customer wanted to go more localized. They wanted a treatment facility just for them and handle their waste, so this way they can meet whatever production demands they had.
Was a circular economy approach important to them?
So for them, there's huge pressure from the Tirupur Pollution Board saying that they want customers to stop polluting their waters. If you don't reach your regulatory requirements, then they're going to shut you down. So for them, it was more on the disposal side. But to solve their issue on the disposal side, they thought that the best way to do it is to kind of reuse their water and reuse as many chemicals as they can in their plant. The more they can reuse, the less that they dispose of, and the easier it is for them to meet their regulatory requirements.
Hilary, can you tell me a bit about the process for you as an engineer? You've considered a lot of solutions, obviously. Why did you settle on carrier gas extraction?
So we want to first recognize that in wastewater treatment, water recovery and low cost is of paramount importance. To bring wastewater to its saturation limit is actually one advantage which some other technologies may not be able to fulfill. One reason may be because these technologies may require high pressure to operate, which actually brings up the capital cost. So by being able to operate at low pressure, CG is able to bring down equipment costs and at the same time bring up the recovery of the desired products because of its ability to concentrate water to its saturation limit. So maybe I could just go on to elaborate on how CG works. CG is basically made up of two main systems, the humidifier and the dehumidifier. Carrier gas extraction, or CG in short, is a thermal evaporative process to concentrate wastewater to its saturation limit. So it makes use of a carrier gas in the humidifier to induce the evaporation of water vapor so that the brine gets concentrated in the humidifier and then gets carried over to the dehumidifier as its water vapor. What happens is that the carrier gas will come into contact with the heated brine, which is the wastewater, which causes the water vapor to evaporate, and after which rises into the dehumidifier and be condensed after coming into contact with the cool fresh water, which is then collected as fresh water in the dehumidifier and can be reused by the end user. As for the brine, it gets concentrated to its saturation limit.
CG is a very energy efficient process, but it also is a very cost effective system in terms of capital costs. Because CG runs at low temperatures, low pressures, the material construction is a lot cheaper. We can go with plastics, resin, fiberglass reinforced plastics, different type of resins, which makes the capital cost a lot cheaper for the client. And that's pretty important for a market like India, where the customer can't afford to buy very intensive capital equipment. They're hoping to buy lower cost equipment that maybe they can recuperate the costs of that capital equipment faster. That's where CG comes in.
Hilary, what sort of reductions can be seen with technology like CGE?
So one of the reductions that we see in CGE is cost reduction. CGE is a low pressure application, and which means that no high pressure equipment is required. And this would be very advantageous to end users because it actually brings down the equipment costs greatly. Next is we see a reduction in chemical use as well as chemical cleaning frequency because fouling issue becomes less of a concern as compared to other desalination technologies such as membrane separation processes. Because CGE is operated at low pressure, so this actually reduces the fouling tendencies and which brings about less use of chemicals and lower frequency in chemical cleaning. Lastly, we can also see that CGE allows concentration of brine to its saturation limit, which is very much desired when it comes to waste disposal. It allows the end user to operate with zero liquid discharge as well as have higher recovery of their products. And this would bring about very huge savings in waste disposal in general.
Stephen, I understand CGE is just one component of the system. Can you talk a little bit about the other aspects?
So let's start from the beginning. Feed water leaves the textile process. It contains a lot of salts, a lot of organics, some phenols, some dye, of course. The first thing it goes through is this MBR process, this membrane bioreactor to take out some of the organics, some of the color. Then it goes through this pre-treatment process of lime softening to remove some of the easier to remove scaling ions. So this way the thermal process can work better later downstream. Once it gets those two groups of contaminants out, then it goes to the CGE system where we produce lots of fresh water for them, and goes through a crystallizer where we produce Glover salt for them to reuse in their textile factory or for selling off to other customers. Then they reconcentrate it to get more fresh water, and then finally at the very end is a small amount of salt that they dispose of, greatly decreasing the disposal rates.
And the plant's been running now for just over a year. Is that right, Stephen?
Yeah, it's been running since June of 2019. They were running it all the way until February. That's about the time when the kind of the pandemic happened and the whole country of India was shut down. So all the textile factories are shut down, and therefore the water treatment facility was also closed. Fortunately, things have gotten a little bit better in India. They actually were able to restart the plant last week, and they've been doing system checks throughout it. Everything seems to be going well, and we're hoping that it'll just keep running for the next decade.
That must be really exciting for you and for them. What are some of the considerations that you have when you're working with customers on new solutions with new technology?
So there has to be a very open communication with the customer uh, because customers who aren't familiar with water treatment might not have a good idea of what can and cannot be done. Um, I think most customers would love this kind of sort of like black box treatment where if you just have wastewater, you send it to your treatment facility and it treats everything. Um, but unfortunately, to create such a black box that treats everything, it's kind of expensive. So you treat water, you get influent quality, and you try to treat to that. You try to build certain capabilities into the system to treat it continuously, and then you add some flexibility to the system. But it can only do so much. If you start saying adding increased amounts of like pollutants in it, increased amount of scaling ions in it, if the concentration comes in 10 times higher than it normally would. These are all things that kind of limit the system and how it performs. So the customer has to understand that uh, we will try to do our best. We will try to make it as flexible as possible for the customer, but we need some control on the upside. So if the customer can maintain their process and create the same type of wastewater, then the treatment process can treat that continuously without a problem. It's not something that all customers uh, understand, but luckily for us, um, our customer in India hired their own on-site water personnel to help with the whole process. So our customer is concerned about his textile production, but he has an internal water treatment body that's working with us to do the whole process. So he immediately says that he doesn't know anything about water treatment, but he trusts us and he trusts his consultant to figure it out. And that's the kind of trust you need, especially for new technologies, is that we'll do our best and we'll give you what we can.
Your role doesn't finish there, though, does it? You've got some expectations to show further improvements.
The customer is actually producing too much Glover salt now, so they're trying to sell it off to other customers in the region. So as he's doing this, he's thinking continuously, "Oh wow, if I can make a little bit of money off of this, then what else can I improve upon it?" So he's thinking of how do I improve, say, the energy efficiency of it? Is there ways to do more energy recovery on the system? Oh, is there ways to get even more Glover salt recovered so I can sell more of it off to other customers? Is there a way to reduce the amount of mixed salts that's being produced so I can even have even less and less disposal costs? Um, the customer is very interested in what the technology can do, and he wants to keep further advancing it for himself. And he's thinking about future projects as well. He has other plants in the area that he is considering to use this technology for, and he also has just friends in the area that he thinks could benefit from this technology. So these are conversations we're having with him for the future.
Any advice for engineers working in this space, Hilary?
One advice is I would want to bring across that it is very important to be curious in learning. I remember when I first joined Gradiant, I was introduced to CGE for the first time, and I was fortunate enough to be sent to the different project sites where I was involved in the CGE pilots. This allowed me to accelerate the gain in my knowledge in CGE because the pilot projects gave me a chance to have hands-on experience in how CGE really works. In addition, The different pilot projects had fit influence of very different water quality. This showed me how efficient and effective CGE can be in dealing with vastly different water qualities. For example, feed entering CGE could be of high water hardness, have high organics and high TDS, which is total dissolved solids. This could be quite difficult to deal with. But CGE is able to handle these complexities, and being on site makes me exposed to the efficacy of CGE as a solution for end users. So by always staying inquisitive at work, I'm able to gain my experience in treating wastewater with complex water quality. And this is also what motivates me at work.
What about to other companies who are working with textile industry, Stephen?
I actually like the business model that we're employing in this region. Wastewater treatment is always an issue throughout the world, throughout many textile companies. And a lot of people try to kind of tackle the issue downstream, meaning at the collection side. I'd recommend other water treatment companies to talk to the actual client that's producing the wastewater. You can do a lot more at the client side than you can downstream after all the wastewater has been combined with other customers' wastewaters. If you can work upstream with the client, there's better chances to do resource recovery for the customer. And then it just makes the whole process of water treatment much easier. If the client can treat their water, and there's less water at the effluent treatment plant, and then the effluent treatment plant has less contaminants that they have to deal with, so it makes it easier for them to hit regulatory requirements. And then that just means the water that's going into the rivers is much cleaner, and people are just happier that way.
I've been speaking with Stephen Lam, Director of New Products Initiative, and Hilary Chiang, the New Products Initiative Engineer, both at Gradiant. Thank you so much for your time.
Thanks, Jo.
Thanks a lot, Jo.